All right, continuing on with chapter 3, we're going to get into indicating states of matter in chemical equations. So there are 3 common states of matter and then a 4th that indicates a state of the situation. We'll talk about that in a second. But our common states, you might guess, are solid. And in a chemical equation, it's indicated by an S in parentheses. Liquid, indicated by a cursive L, or an italicized L, and gas, as you might have guessed, by a G. Now the 4th state that we often will see in chemical equations is aqueous, and that's denoted by an AQ. And what that means is that when we see the AQ, that means that whatever the chemical substance is, it's in a homogeneous, if I can spell homogeneous, mixture with water. Okay, so for example, salt water would be denoted in a chemical equation as a sodium chloride AQ, meaning that we have sodium chloride in a homogeneous mixture of water. So if I do an example of a chemical equation showing all of the states of matter, I'm going to have, for example, sodium plus 2H2O will give me some sodium hydroxide plus some hydrogen gas. Oops. Okay, and when I put in the states of matter here, if I'm talking about solid sodium and liquid water, I get sodium hydroxide aqueous, a solution of sodium hydroxide, and hydrogen gas. This, by the way, is a very fun thing that if you ever get a chance to do, you should see what happens when you put solid sodium metal into water. It's very entertaining. It explodes. Be safe. Don't try this at home. That sort of thing. So the next thing we want to talk about are patterns of reactions. Okay, and there are several different types of reactions. The first of which we're going to talk about are called combination reactions. All right, sometimes called synthesis reactions. Right? And to use sort of generic chemical symbols, I can write a generic combination or synthesis reaction as A plus B makes some C. Right? A and B come together to make a new component. And to describe it in words, we're going to talk about this in terms of 2 or more components combining to make something new. Right? So the opposite of a combination or synthesis reaction is a decomposition reaction. And I'm going to start writing RxN for reactions, just because it gets tiring to write the whole word reaction every time. So a decomposition reaction, the generic version of that, would be exactly the opposite of a synthesis reaction. So if I have some of component C breaking down into 2 or more things, right? And we can talk about this in terms of something coming apart. Right, our third type that we're going to talk about, and we've kind of already mentioned it in the previous video when we were balancing equation, is a combustion reaction. Okay, and the defining characteristic of a combustion reaction. Characteristic. One of those funny words that seems like it has too many letters for the type of word that it is. But the defining characteristic of a combustion reaction is something reacting with O2 gas. Okay, if you have oxygen gas by itself as a reactant, you are talking about a combustion reaction. Okay, that is it. All right, so quite often we're talking about combustion reactions in terms of reacting with a hydrocarbon. So for example, C3H8 plus 5O2. And I should be a good professor and write in the states of matter as I go. So some gaseous propane plus oxygen gas. Whenever we have a hydrocarbon reacting with oxygen, we always get the same products. We get CO2 and H2O. And 4 H2O gas, so water vapor. Right? And this is kind of an important thing, so I'm going to write it out. Reacting a hydrocarbon. Okay, thinking about a hydrocarbon, what are the words there? Hydro and carbon, so we're talking about hydrogen and carbon. Okay, like propane there. Reacting a hydrocarbon with oxygen, we always get CO2 and water. Those are always the products of a combustion reaction with a hydrocarbon. Okay, so let's do show some examples here of the various types of reactions not in a generic form. Okay. So if I have some N2 gas plus 3 H2 gas, we'll make 2 molecules of ammonia gas, NH3. Right, this is a good example of a combination reaction. All right, we get 2 or more things coming together to make a new product. Two, potassium chlorate, solid, becoming 2 potassium chloride, solids, plus oxygen. All right, we get something that breaks apart into more than one thing, or breaks down, or decomposes. Keep forgetting to put the states. CO2 gas plus H2O gas. Right, I need to balance this. And if we balance, we end up with a reaction that looks like 2CH3OH, which is methanol, plus O2 gas. There should be 3 there. 2 CO2 gas, and 4 waters. Okay, so taking a look at what we have here, we have something reacting with oxygen. Okay, whenever you have a component reacting with O2 gas, we have a combustion reaction. Okay, I think I'm probably going to stop this video right here, even though it's a little bit short, and we'll continue on our next video talking about Avogadro and the mole.